Hey guys, this is Ohm's Law. Ohm's Law states that voltage equals current times resistance. Okay, so voltage and resistance are directly proportional. So that means that whatever happens to resistance, the same thing is going to happen to voltage. So if the resistance increases, then the voltage increases. The resistance decreases, the voltage decreases. Okay, as long as your I stays constant, stays the same. Okay? Current and resistance, current and R, I and R, are inversely proportional. So whatever happens to one, the exact opposite is going to happen. Okay, we're going to go through the problems that you were given on the Google Slides now. Okay, bear with me. This is my first time using this little pen drawly thingy I have here. So my handwriting, it's already sloppy enough, but probably even worse now. So, okay, so the toaster oven has a resistance of 12 ohms and is plugged into a 120 volt outlet. How much current does it draw? Okay, so the resistance R is equal to 12 ohms. Ohms is looks like a little horseshoe symbol. Okay, that's the symbol for an ohm. Okay, and then you have voltage. Voltage, it's 120 volts, which is the standard in the United States for any outlet, at least any regular outlet in your house. And then we're looking for current, which this symbol or variable that we use for current is I. Okay. So the formula for Ohm's law says that V equals, which is the voltage, equals the current times the resistance. So our voltage in this case is 120. We don't know what I is, so that's going to stay I. And then our resistance is 12. Okay, so right now it's I times 12. We need to get the I by itself. So obviously we are going to divide by 12. Okay, we always do the opposite operation. So we're going to divide both sides by 12 so that we can cancel the 12 out on the right side. Cancel that out on the right side, and we're left with it on the left side now. Okay, so now we take 120 divided by 12, which is going to give us 10. Okay, and that's going to equal our I. Now I left space here for our unit. Okay, the unit for current is amps, so we're going to put capital A. Okay, let's take a look at the next problem. It says a motor in a toy car needs 2 amps of current to work properly. If the car runs on 4 1.5 volt batteries, what is the motor's resistance? Okay, so our 2 amps, that's current. So we're going to write I. Oops, I hit a button here. Okay, so I equals 2. Oh man, this pen, it's really tricky because there's this button that's right where my fingers are. And if my fingers hit it, it messes it all up. So bear with me here. Okay, so it's 2 amps. And then our voltage gives us, this is a little tricky because it's 4 1.5 volt batteries. So we're going to have to do 4 times the 1.5 to give us our total voltage, which would be 6. Okay, so 4 times 1.5, that gives us 6 volts. Okay, and in this problem, we are looking for our resistance. So again, we're going to start with our standard formula here, which is V equals I times R. Our voltage is 6 volts, okay, equals our I, which is 2, times our R. So in this problem, it's 2 times R. So again, opposite operation. We're going to divide by 2, both sides. Okay, cancels our 2 out. So now we're left with 3. 6 divided by 2 is 3, equals R. Okay, I did forget to leave some space here, but the unit, okay, the unit for this would be an ohm. Okay, it's that little funky hat thing. There you go. Okay, next problem. How much voltage would be necessary to generate 10 amps of current in a circuit that has 5 ohms of resistance. Okay, so we're looking for voltage. That's our question mark this time around. It generates 10 amps of current, so I is equal to 10. And then the resistance, R, is equal to 5 ohms. Funky little hat thing. Okay. Then we use our formula, V equals I times R. Plug it in, or V. We don't know what V is, so the V is going to stay V. We do know our I, which is 10. We're going to multiply that by our R, which is 5. Okay. So no algebra needed because all our numbers are on one side, or letters on the other side. So now we have V equals 10 times 5, which is 50. And it's voltage. Voltage is the easiest one to remember because our unit is the same as our variable. So it's 50 volts. Okay, next one. What current flows through a hairdryer plugged into a 120 volt circuit if it has a resistance of 25 ohms? Okay, so in this problem, we're looking for current. Okay. Voltage, it's a standard outlet of 120 volts. And the resistance is equal to 25 ohms. Okay. So again, V equals I times R. Our V is 120 equals our I, which we don't know, so that's going to stay I, times our R, which is 25. Okay. So I times the 25 there, we have to divide by 25. It's going to cancel out our 25s here. Okay. Now we're going to take, if you have a calculator available or anything else, you're going to take 120. You're going to divide that by 25. Okay. Equals. So we're going to get, if you put that in the calculator correctly, you're going to get 4.8. Okay. It's current. So we're looking at a unit of amps equals I. Okay. And let's go to the next one. Okay. An alarm clock draws 0.5 amps of current. Okay, so our current is equal to 0.5 amps when connected to a 120 volt circuit. So voltage, 120 volts. And it wants to know the resistance. Oops, I pushed that darn button again. Okay, so it wants to know, there we go, resistance. Okay. So V equals I times R. So our voltage is 120 equals I, which is 0.5 times R. Okay, so now this problem, we're going to divide both sides by 0.5. So you take 120 divided by 0.5, and that will give you 240. Oh, I hit that button again. There you go. I'm telling you, that button, if you saw this pen, the button is right in the way of your fingers on the pen. Okay, so you get 240. Its resistance, R, so it's going to be ohms equals your R. My finger got in the way again. There we go. Okay, and that's all the problems. So hopefully you understand it a little better seeing it this way. If not, you could always look on the Google Slides too, nice and neat in there. It's just the handwriting is bad enough to begin with. So thanks a lot.